Hi, I'm John Rinaldi from Real Time Automation. The following presentation is called The Third Wave of Internet Evolution. It's an accumulation of 2 years of my time looking at all the technologies that are changing, the cultural changes that are happening, the customer requirements that are vastly different than they used to be, the changes to business models, and everything else that's happening in industrial automation. I also provide some recommendations about how you can navigate through these changes. I hope very much that you enjoy the presentation, and as always, you can contact me directly on our homepage, rtaautomation.com, and hit the Contact Us button. Those emails will come directly to me. So without further ado, let's get started. Good afternoon, this is John Rinaldi from Real Time Automation, and this presentation is entitled How the Third Wave of Internet Evolution is Going to Affect Your Manufacturing Automation Systems. I'm going to tell you a little bit about me a little bit later in the presentation, and for those of you in the audience today, I've got a free gift that I'll be telling you about in just a little bit. So let's get started. There's been 3 waves of internet evolution. The first wave, website connectivity. You all remember that. Everybody has to have a website. Everybody's brother-in-law was going into the website business. There was this absolute rush to have a website, and it became the thing to do because everybody thought that that's what was going to lead to internet riches. The second that led right to the second wave of connectivity of internet evolution, which was apps, more apps. Everybody was doing an app. Yelp, Uber, Facebook, Skype, Kindle Reader, Twitter, Dropbox, YouTube, Gmail. I could talk and talk about apps for all day and all week because there are probably tens of 100 million apps. I don't know. There's a lot of apps. So that was the second wave of internet connectivity. I went to a college, asked me to come and be a judge at their innovation fair. And I said, fine, that sounds like fun. And I go there, and there were 19 different student groups, and they all had an app. And one of them was the Facebook of the hunting industry, and one of them was the Skype of this industry, and the Uber of that industry, and on and on and on. And I rated them all low, and they didn't ask me to come back again the next year. So I think I burned that bridge. Third wave. What was the third wave? Of course, the Internet of Things, and that's where we are today, and which is changing everything. There's all kinds of things that are changing. That's changing the demographics, their security, or sustainability around the world. There's good and bad, of course, from the Internet of Things, but there's no question it is changing everything. The newspaper industry, my home newspaper, is now so thin that I cannot even wrap fish in it. You have to take a whole week's worth of newspapers just to wrap fish in it. The television industry, I just read the other day that AT&T has now 3 different ways they're promoting that you can stream television right to your house. You don't need the cable company anymore. The music industry, we all know what happened to the Barnes and Nobles of the world. The Amazon has killed us, irrevocably changed that industry for good or for worse. The taxi industry, I happen to love Uber. I don't know if they're going to survive, but we'll find out. They certainly have caused a lot of angst in the taxi industry. The brokerage industry. The big thing in the brokerage industry now is automation, having automated software systems that are going to interact with you and do your financial planning. One of these systems is now up 56% on some portfolios. So I'm not sure that I want to talk to an automated robot about my financials. Travel industry. We all used to use travel agents. If you were a travel agent 25 years ago, you are not a travel agent today. That industry has been irrevocably changed. The medical industry is all kinds of incredible things going on with the medical industry. Genome mapping. Genome mapping used to be a commodity. It used to cost it used to be a luxury, It used to cost hundreds of thousands of dollars to map your genome. It is now a commodity. You can now get your genome mapped for a few $100s. What does that mean? That means that soon they will be able to look at your genes, tell you when you're going to get sick and how you're going to get sick. Incredible. They're taking blood, and they're actually starting to use blood as a data storage mechanism. Unbelievable. They have put movies into that. You can store trillions and trillions of bytes of information in a drop of blood. So they've actually stored a movie out there in a drop of blood, retrieved the movie, and played it. Incredible. That would make all of our data storage needs go away. It's absolutely incredible. Another thing that's going on in the medical industry, they're equipping all of our clothes, all of our shoes, everything on us is going to report its data. I'm not sure I like this. I don't want my tennis shoes reminding me that I haven't exercised in the last week and a half. I don't need that. I don't want IoT nagging devices in my life. I don't know about you. The automobile industry. Oh, geez, what's going on with the automobile industry? For a while, it was entertainment on wheels. Now it's internet connectivity on wheels. And with driverless cars, it's going to change everything again. Did you know? Does anybody in this room know what the #1 occupation of the American male is? That's right. It's driving. 1 out of 9 American males is a driver, at least for part of his job. And those jobs are tenuous. Someone came to me and said, I think you're becoming a truck driver. I told him he better rethink that decision, because there may not be truck drivers in 5 years, let alone 10 years. And of course, the manufacturing industry. I would submit to you that today is the slowest rate of change in manufacturing technologies, processes, people, and organizations that you're ever going to experience in your career. It will never again move this slowly. The technology is changing. Our culture that we're changing of manufacturing automation, where we used to have, the manufacturing used to be its own separate entity. That's all done. The business models that we've used, a lot of the business models are being shattered. The customer requirements have expanded tremendously compared to when I started 25 years ago. At that time, the thing was get production out. We want high quality and we want production. We really just have 2 requirements. Now we've got all kinds of new requirements around gathering data, statistics, and all sorts of things. And our organizations are reforming into all kinds of new kinds of things. And we're all just running like hell to try to keep up with all these changes. It's really tough. Let's talk about the culture. One of my favorite topics. We all know millennials have arrived, and they have arrived in force. This is the first year that there are more millennials in the workforce in manufacturing than any other group. So the baby boomers like me, I'm kind of at the tail end of the baby boomers, are on the way out. And what does it mean to have the millennials in the workforce? Well, it means that our training requirements are changing, because these people are pretty technology oriented. But they assume that there's connectivity to everything. They want to walk up to a pump and say, hey, how do I, pull out their phone and go, how do I get the vibration on that pump? And they expect to just be there. We're losing an incredible amount of operator expertise as the baby boomers retire. We had people, guys usually, that could stand in a refinery, play with the buttons, look at all the screens, have feel the vibrations, and know what was going on in the refinery. That doesn't exist anymore. These people also have different values, they have attitudes, communication styles. I'll tell you a story. I've got a lot of stories today. Number one, I was on an airplane. There was a young woman sitting next to me, and we started to chat a little bit. And she says, "My best friend's fiance just died." How horrible! And the key word here is best friend. How horrible! What did you do? What are you doing? And she goes, "Well, I just texted her my condolences." And in my generation, you don't text condolences. You go see the person. I was horrified. And all I could think of, SRY, BF, dead. I guess 11 letters. What else can you say? Jeez, I mean, it's just totally different. I didn't understand that kind of thing where you text condolences. We have, in the first time in history, we have younger workers supervising older workers. Because we have younger workers that are so technically adept, they're coming in and they're taking positions that normally they would have to be there 10 or 15 years to get. but they're being promoted quickly because of their technical knowledge. And it's causing some angst, because it used to be you came into the organization at the bottom, and over the years you worked your way up and you retired at some upper level position, and that's just the way it was, and it just kept revolving like that. Now that's changed, big change. So we've got a lot of generational change in our manufacturing systems. And there's customer requirements. As I said before, lots of new customer requirements. Connectivity is just taken for granted, but we want all kinds of connectivity. We want our phones connected on the manufacturing floor. People want cameras on the factory floor. They want to be able to look at these machines from remote places. They want to have audio on the right at the factory floor, so you can do video. You can send audio transmissions. We haven't ever had to deal with bringing audio and video right out to a manufacturing system. But that's happening. Printing, a lot more printing now coming right to the factory floor. And sensors. We are going to be flooded with sensors over the next 10 years. And those sensors, I would submit to you, are going to be on Ethernet. And I'll tell you about that in a little bit. Let's talk about security. I submit to you that nothing is secure. There is no security. All the things on the screen have been hacked. If you had HP light bulbs in your house, it was probable that the kid next door was able to turn your lights on and off and change the colors and do all the other things. If you're driving cars, that stuff got hacked. Hello Barbie was saying some things that Barbie shouldn't say. And there was a great concern, for example, when Dick Cheney was vice president, that his pacemaker would be hacked. And they were thinking how they would stop that. So there's a lot of, essentially you can think of anything that's connected is going to be hacked. And what does that mean for your personal life and for your business? I was at a presentation by John Kelly, Secretary of Homeland Security, in February. This is before he took the job as Trump's chief of staff. And he said three things that I was just stunned by. The first thing he says, if you think your manufacturing system hasn't been hacked, you're wrong. Oh my God. He said every manufacturing system in the United States has been hacked at one level or another. And if you think you can prevent your system in your factory from being hacked, you're wrong. And thirdly, he said, identify your most critical processes and take them offline. That was all stunning to me. Take them offline. Yes, he meant take them offline. If you have to walk out there with an iPad in your hand and write down values for that offline system, you have to do that, because there is no way to prevent somebody from getting into your system. He said that there are very, very smart people all over the world. They are financed by nation states that are not necessarily friendly to us. Some of them are friendly, but they're in there to see what they can do if they choose at some point in the future to do something. They will have the record of how to get in and what to do. Very, very scary. He said, I did not come to this conclusion lightly. I had to be dragged kicking and screaming to it, but I really believe this is the situation, and I would be remiss if I didn't tell you exactly what I thought. Very, very scary. Let's go about some of the new requirements for analytics. Let's talk about this. Everybody's talking about analytics. Everywhere I go, I talk to somebody who says to me, we're building our own analytics system. And I go, oh, really? Why are you doing that? Because we're really smart and we really know how. They don't usually say it that blatantly, but they couch it in other words, but that's what they mean. But I say, hey, aren't the guys at Amazon kind of smart? And some of the Microsoft people seem kind of smart. And GE's got some Predix people that are pretty good. And Google's seems like there's smart guys at Google's, and why can't you use those analytics systems? The problem is with all these analytics systems, and what you don't realize when you're using them is that there's bias built into them. There's always bias built into them, and you'd have to check whose bias do you want when you're implementing analytics systems. Let's talk about the Internet of Things now. Okay, what's with the Internet of Things? We've been moving manufacturing data off the manufacturing floor into enterprise systems now for 25 or 30 years. We've been doing that forever. Since the first PLC went in, we're trying to figure out how we can get the production data in. But now what's happening is all of these companies, Accentures and Detroits and Deloittes of the world, seeing that there's a ton of money, they're going around to the CEO and the board of directors and they're saying, you gotta invest in IoT because there's $11 trillion that needs to be made of IoT. Oh my God. But the question that they can't answer as they are pushing the CEOs and the board of directors to do this is how. There are some companies that have made some attempts. For example, one of the things that is talked a lot about is the ThyssenKrupp elevator systems. They have equipped elevators all over the world with connectivity so that these elevators can report their status to a control center in Germany, collect data about their operations so they can improve that. They collect downtime information as soon as an elevator goes out of service or something is starting to go wrong with an elevator, say that the doors are sliding open or closed a little slower than they're supposed to. They get that information and they're able to get the repair parts ordered, get them on a truck, and possibly get there to fix the thing before the hotel even knows that they're out. Kind of cool. But again, the question is how? What's the business model behind that? Will the Marriott Hotel or the Hilton Hotel or even the Courtyard pay a lot more money for that service, or do they not care? If they've got 4 elevators and one of them takes a day to get fixed, hey, we still got 3, and when you get here, fix it when you get here. I don't know if there's a lot of money to be made in doing stuff like that. Maybe there is, but there's not a lot of business models around. I was at a company that makes paint spraying systems, and they said that they were under pressure from their board of directors to get IoT done. So they managed to move data from their spraying systems up into the cloud, and they all congratulated themselves, and they said to me, John, do you have any idea how we can make money on this? How do we commercialize this and make money on it? And I said, well, wait a second. You guys do paint spraying systems for Ford and Chrysler and companies like that. If I'm Ford and I buy your paint spraying system, I'm not going to let you send my data to the cloud. I own that data. I bought that paint spraying system. Are you guys sure that your customer is going to let you move that data out into the cloud? Isn't it belong to them? Well, we don't know. Well, then secondly, what's the business model to make money off of it? Are you going to do something with it and then sell it back to Ford? Boy, that's even a worse proposition. So it's great to talk about IoT and manufacturing, and there are certainly some advantages and some things you can learn and do with the data, but there's still a lot of work to be done on business models as I see it for these things. Let's talk about technologies. Lots of new technologies. Low complexity Ethernet. There's companies right now working on chips allowing you to put a chip into a sensor, a vibration sensor, humidity sensor, temperature sensor, that for $1 you'll be able to connect it on Ethernet, because Ethernet is the network of the future. It's called low complexity Ethernet, and I can't wait for it. Robots, all kinds of cool things going on with robots. The latest thing I saw, which is really cool, is there's a lot of researchers working on how do you get robots to collaborate automatically such that you don't have to tell them specifically what to do. They all have kind of a goal, they all have some rules to follow, and they all collaborate to get things done. I saw an example of 50, maybe 10 robots, small ones, real tiny ones, that were dragging these bricks along to try to build a little house. It was really, really interesting. They all have rules about where these bricks would go, and they just kind of go there and drag them over. It's really fascinating stuff. Network speeds, bandwidth. We are on the verge of an explosion in bandwidth. 100 gig, 200 gig, 400 gig networks. Massive bandwidth we're going to get. It's going to change a lot of how we do things. Adaptive manufacturing still hasn't rolled out as fast as many of us thought it would, but I still think that's got tremendous opportunities for doing a lot. OPC UA, which is one of the big things I'm going to talk about here in a few minutes. Then there's machine learning. All kinds of cool things going on in machine learning, and I see a lot of presentations about that, about different ways of making machines figure things out and learn things so that they don't have to be programmed. I can tell you that I think in 10 years, certainly, there'll be many fewer people doing programming, that'll all be automated. Linux containers, if you don't understand what Linux containers are, they're essentially the VM of Linux and the VM of Linux with the Linux, and now you can put those containers in all kinds of things. Cisco is putting Linux containers right in a Cisco switch so that you can actually run applications right in the switch. Somebody's going to put a PLC in that switch. Then if I was a Rockwell or a Siemens or anybody making PLCs, I'd want to put my technology in there and do be first because somebody else is. Blockchain, the technology behind Bitcoin, yes. Massive distributed databases. The push for open standards. I hear this from companies all the time. They're tired of proprietary. They want everything to be open. They want open standards. TSN, time-sensitive networking. The ability that's going to bring determinism to Ethernet, meaning that we'll be able to send messages over Ethernet that will arrive precisely when they're supposed to arrive. Highly deterministic Ethernet using TSN technology. Facial recognition. Chinese are using this to track jaywalkers. I suspect that in the future, when you walk up to a machine, it's going to look at your face and it's going to allow you to do things. Instead of having a security badge, instead of having fingerprint identification, it's going to look at your face. Big data and cloud computing. Unlike what Microsoft would tell you, I think these things are passé already. They're already dead. We are not going to be doing a lot of big data databases. We are not going to be doing a lot of cloud computing, at least in manufacturing. What we're going to do is going to be brought into the manufacturing system. It's going to be done locally. So we're going to have big data systems. We are going to have cloud computing, but it's all going to be within the confines of the property, not off in the cloud someplace. All of this stuff is going to lead to the combination of IT and OT developing your smart factory. Let's review. What is OT and what is IT? OT is where you have very tightly coupled platforms. You have I/O producers and consumers, and they are really strictly defined how they communicate, and they can't be changed very much. It's very rigid. There's very weak information models. IT systems, on the hand, are very loosely coupled. For example, you could build a website for dog leashes and then hook up to Amazon and get a list of books on dogs that would show up. And if you decide tomorrow that the dog thing wasn't working for you, you want to switch to cats, boom, you'd get a list of cat books. It's the way IT systems work. We haven't worked that way in manufacturing. In manufacturing, everything is really strictly defined and well controlled. So how do these things meld? Well, that's a big problem, melding these IT and OT systems, but it's going to happen. Here's some of the things that are going to force it. The Purdue architecture. If you've been around manufacturing for any length of time, you've run into the Purdue architecture. Somebody from Purdue defined this about 35 years ago, and it starts at the bottom level with sensors and actuators, and then there's controls above that, and above that is the supervisory controls, and it goes all the way up to the enterprise. And we've been building systems like this for 35, 40, 50 years now. I think that's over. The new system is going to look like this. It's going to be a great big ring that's running 200, 400 gigabits. And everything in the factory and in the business is going to run on that ring. Motors, controllers, accounting systems, all the connectivity to phones and iPads, everything you can imagine is going to run on the same thing. And that's all going to be driven by TSN and OPC UA. Time-sensitive networking, deterministic Ethernet, and OPC UA. In this kind of system, a motor will be able to be sending data to the PLC at the same time accounting's running reports on the same network. You could be done. Don't necessarily know it'll be rolled out this way, but certainly as the possibility is there to do this. And that'll be radically different. The advantage to this is that we can put the same security on everything because it's all Ethernet. Everything's going to work using the same technologies. It's going to be all IT technologies, not manufacturing technologies. All the old stuff, the I/O links and the device nets and the Profibus, that's all good. That's all, I think, dead. And there's a lot of new stuff here that all this TSN and OPC UA is going to replace this. So let's talk about OPC, OPC and OPC UA. OPC is the original one, OLAVE for process control, and this started back when we were putting PCs, started to put PCs on the factory floor. People needed to connect up to devices. So what they would do is they would write drivers. And it was a mess because every project you'd rewrite the driver. Okay, I got to talk to a valve today. I got to write a driver for the valve. Tomorrow, go to another job and I got a flow meter. Write the driver for the flow meter. And you were just, you're just rewriting these drivers all the time. And it was very difficult. It was time consuming. It was very costly because you needed a very educated person, very well trained. It was very error prone. And you had to deal with all the early Windows issues. I don't know if any of you remember Windows 3.1 and Windows for Workgroups and all of those editions of Windows that constantly had problems. Well, OPC solved that problem by putting a driver there. If you needed to talk to device X, these were standard drivers. You could just buy a driver for device X and it would work. You drive a driver for device Y and it would work. And companies like Kepware and Natricon made millions of dollars doing this. How did that work? That worked using something called Microsoft COM. And this is OPC Classic I'm talking about now. So you would have over here in the driver would be able to have the proprietary part that knew how to talk to that device and all the specifics of that device, and then the COM part that knew how to talk Microsoft COM. And then any application that was COM enabled could communicate to any device that had a driver. So you could go into Excel and you could have a cell location in Microsoft Excel that would be able to get the flow out of the valve, out of the flow meter. Very cool, very easy to use. Bunch of problems with this though, because this was only one platform, Windows, and then Microsoft went and obsoleted COM. Now what do? There's no more common object models, got rid of it. The security was very limited in this structure. The data typing, very limited. Data modeling was almost non-existent. So OPC Classic had a lot of limitations. And so that was replaced by OPC UA, the information architecture. There's four things that we need to talk about when we're talking about OPC UA. There's four big benefits that I want you to remember. One is security. It uses the same certificate-based security that you use when you talk to your bank. No different at all. So it's got the ability to upgrade that security easily because OPC UA is built on Lego blocks. So if there's a new way to do security, you can plug that in alongside the old one. So they'll be able to prove it's expandable and upgradable. Information modeling. This is one of the things I thought was the coolest thing. A client device can come to a server device, browse through its object model. Oh, it's a pump. Okay, well, it's got a motor. Oh, the motor's got some flow associated to it. Oh, it's got a channel 2. And then there's a temperature under channel 2. And then the client can say, oh, I found this temperature in channel 2. Send me that every 5 seconds. And it comes. Very interesting technology. We've never had that before in any kind of communications architecture before on the factory floor. Kind of combines the IT and OT stuff together. Transports. How do we move the data? We've got encodings. We've got different kinds of encodings. We've got different kinds of transports. So OPC UA, because it's this Lego block based, you can add different transports. So right now it supports a web services transport. There's a binary transport for very optimized, highly optimized devices. There's HTTP, HTTPS transport. So whatever comes along, OPC UA can handle that kind of transport. And then it's very scalable. From chip level all the way up to big servers, you can run OPC UA in any of these devices. That's why I believe that OPC UA is the software architecture of the future that's going to enable that big ring structure and the ability for people to be talking over, be talking from a motor to a controller at the same time accounting is running reports. There's actually 6 reasons why I think that's going to happen. One, because it's an open standard. There's no Rockwell or Siemens that is really the vendor behind this thing. It's totally open technology driven by vendors. It's adopted by lots and lots of trade organizations. I think 40 or 50 or 60 at the last count. The Undersea Oil Trade Association is one of the really cool ones. You would think, what does it cost to move that oil well out to the North Sea? What is the major cost? Is it the steel to build the thing? Could be. Is it the dragging it out, the huge structure out there? Is it equipping it with all of the devices that have to be on there? Actually, the number one cost for that oil well is integration. Getting all of those devices on that thing working together. That is the biggest cost. So what they decided to do is that they decided that why don't we use OPC UA as the infrastructure for all these devices on that oil well? Then we'll just implement the information model for that particular device. So a drill bit will have a specific information model that they'll use OPC UA, the open standard, to move the data around, and boom, all of a sudden the integration problems get a lot simpler. So they've adopted that. Same thing in the building automation industry for the exact same reason. When you talk about a great big building like this one, you've got lights, you've got temperature sensors, you've got motion sensors, you've got security systems, you've got all of these things that you want to integrate into the building's control center. And it takes a lot of effort to do that. OPC UA is going to solve that problem. It's also flexible, adaptable, scalable, because as I talked about, this Legos-based technology, it's cloud ready, so you can move data to the cloud if you want. We talked about how secure it is, and it's really an architecture. It's not just a protocol. This is an architecture where you can load into it, build into it, architect into it the kinds of tools that you need. So if you need binary encoding, well, it has binary encoding. If you need XML encoding, it has XML encoding. But if you need a third encoding, you can just add it, because it's an architecture and it's not a fixed protocol like so many other things. Big drive to open standards. Here's an example of what this buys us when we go to open standards. So think about this. This is a packaging system. Some of the people in the audience said that they were involved in packaging. So here we have, for example, a filling station, a capping station. Okay, capping. The capping is a cool thing. So the traditional way of doing this is you buy the capping station from a company that makes capping stations. You buy the labeling and sealing station from a company that makes labeling and sealing, and so on. And none of these things hook together. Then you've got to spend hours and days and weeks and months maybe to get all of these different pieces to work together. Really difficult. But if you put OPC UA on that, again for the same reason as I just talked about with the undersea oil well, with the building, all of these systems can now communicate. And then they went one step further in the Packaging Trade Association. They added something called PACML on top of that. So not only was the Ethernet layer the same, the TCP/IP layer the same, the OPC UA layer the same, they added this PACML standard on top of that, so all of these machines not only could talk to each other, they looked the same externally to the MES system or ERP system or whatever PC clients they have, so that all of this stuff could be easily integrated. Massive improvement in integration, massive improvement in how fast you can bring a machine online, massive improvement of how easy it is to grab data that you might need out of this system. This is the future. What we have today is pretty much old OT systems where we use cyclic communications. A controller sends out some kind of data. This is I show Allen Bradley, equipment here, but it's not necessarily Allen Bradley. They all work the same. What we have here is cyclic outputs and cyclic inputs, and this thing starts up and it runs forever like that, and it never changes. I could submit that that's old and going away, and that the new way is a publisher-subscriber kind of system. That when we have that huge deterministic ring network, what we're going to have is motors that will just publish their speeds out on the network, and control anything that's interested, like a controller, will just grab that data. And because it's all deterministic, that we've set up there's a director that would set up the deterministic communications, because that motor information, when it gets published, has to get to the controller in a certain period of time, that all this will happen deterministically. So I believe that we're on the cusp of really changing completely how we architect manufacturing systems. Okay, but right now it's the Old West. We're trying to deal with all this. How do we go from where we are to that? And it really kind of leaves us lost and unsure and perplexed and all this kind of stuff. It's really difficult to know what to do. So I've got a couple of ideas. The first thing I'd like to tell you is that you have a new job, and that's security. Everybody has to be thinking security on every project, because your livelihoods really depend upon it. There are people out there that will want to be in your manufacturing systems. They will want to do things, and those things are not going to help you get out more production. So it's a project that's never going to end, and it's something you have to pay attention to, not once a week, not once a month, but really every day. Second thing is Ethernet. Ethernet is the future. All this other stuff has got to go away. You've got to be thinking Ethernet. When you're putting together new systems, they've got to be Ethernet oriented. And you need to start using OPC UA. That is the network of the future. There's some training materials I'll talk about in a second that you can get for that. And you need to plan for this faster and flatter kind of infrastructure as you're thinking about how to architect new systems in the future. All right, story time. I'd love to tell stories. I was at a Microsoft conference, and there was a guy at the Microsoft conference who used to work for Google. And he told a story of how when he was at the Google building he was in, they have restrooms, but they only have them on the first floor off the lobby. They have this huge men's restroom, and they have this huge women's restroom right on the first floor. And so in the middle of the afternoon, he heads down there. It's completely empty. There's 35 or 40 urinals, and he takes urinal number 3. Excuse me. All of a sudden, there's a guy at urinal number 4, which is not really nice protocol. And he looks over, and it's Eric Schmidt, CEO of Google, standing next to him. Well, okay. That's interesting. I guess Eric can take whatever he wants, whatever urinal he desires. So they're washing their hands up, and he's CEO of Google. He's got to be nice to this low-level employee, and he says, "Oh, so what do you do?" Kind of in that kind of tone. And instead of saying, "I'm Joe Smith," and in the Chrome group, he was actually building Chrome. He was the manager of the Chrome development. He says, "I'm saving the world from Internet Explorer." And all of a sudden, Eric Schmidt's eyes light up, and he goes, "What did you say your name was?" "Oh, I didn't say my name." He said, because he had told him something that was really interesting in a way. So the story, the object of the story is that, the moral of the story is that you never want to just say, "I'm Joe Smith, and I'm doing this." You always have to say, you have to have a way of presenting what you do in a way that's going to be interesting to other people. So he had ended up having a conversation with Eric Schmidt because of the way he phrased the way he was doing his work, and that conversation went on for 20 or 30 minutes. Very nice. So I spent the next 4 hours trying to figure out what I could save the world from, and I came up with saving the world from inaccessible data, which is what our company's mission is. So I've been working with doing these kind of presentations and thinking about manufacturing systems for a long time now. I've got an electrical engineering background. I worked at Allen Bradley for a while, and I founded Real-Time Automation way back in 1988. I actually had hair then. And we work with people like you guys to solve connectivity problems. And I'm an author. I've written 4 books, the Industrial Ethernet book, the Modbus book, 2 books on OPC UA, and we published something called the Industrial Automation Newsletter, the world's best industrial automation newsletter, which is unfortunately not very difficult to do. Everywhere I go, unfailingly, someone will come to me and say, "You're John Rinaldi from the newsletter," and I go, "Yep, guilty." So you may want to get on that. You may want to get on that newsletter list. So what do we do at Real-Time Automation? We have off-the-shelf connectivity products that connect all of these kinds of systems. So we're saving the world from inaccessible data with all this off-the-shelf connectivity. We also do device connectivity. For those of you in the room who are building devices, we can add all kinds of connectivity to your devices. For example, all the ABB robots, when you see a car line, have our Ethernet IP in the arm for the tooling end. They also have Ethernet IP in the background, on the PLC side to talk to the PLC. So we do a lot of device connectivity. We also do some custom engineering, and we do some legacy work. What does legacy work? It means keeping legacy systems running. What we see right here on the screen is the Bellagio Hotel. How many people have been to Las Vegas and seen the fountains? We have a box in the water in each one of those fountains that converts the signals from an old drive, that because the PC that's running this doesn't know how to talk to new Allen Bradley drives. So what we did was we converted and made the new Allen Bradley drives look like the old drives. They were scrounging the world trying to find old drives. And now with the system that we put together, they can just put in these really great Allen Bradley drives, and they run those fountains just perfectly. So, in summary, I'd like to say is that this whole third wave of evolution, the IoT and everything else that's happening, including the changes in the culture and the security issue and all this, really requires us to rethink how we're going to do business. And a couple of questions you should be asking. What data do you need to collect, and how can you leverage it to enhance what your company's trying to do? Number 2, how can your existing businesses profit from a very fast very fast network with a lot of bandwidth? What kind of problems do you have today that something like that might solve? And third, how can you leverage some of all those new technologies I talked about and create whole new responsibilities? So, for next things you could do is if you send an email to us, I said there was a free gift. We have a free gift webpage. Go to the free gift webpage, and you'll be able to, because you saw this presentation, be able to pick a free book out, and we'll send it to you. Or you can phone me to discuss OPC UA or connectivity issues, or you can contact me about any of our factory floor solutions. And I'm available on rtaautomation.com. You can go there. There's a contact us button. I'll get that email, and we can chat. Thank you very much today for your presentation, for your attention. I really enjoyed being here. Thank you again for inviting me. You've got a lot of cool stuff going on, and I'm looking forward to talking to some of you afterwards. So you have a great day.